Now you'll notice the angle is negative. If you remember in algebra, negative angles reflect things over the y-axis, which we could certainly do with the trig functions. It just tends to make things a lot more difficult. So I would prefer to use what we talked about yesterday with even and odd. So if you look, yesterday we wrote down that sine was an odd function. And I had you write that that meant sine of negative x was equal to what? Since sine was odd, we said if the angle was negative, that was the opposite of the original. So because sine is odd, if there's a negative on your angle, you can actually just pull it out in front of everything. Now cosine is an even function. We wrote this down yesterday, that cosine of negative x was equal to a cosine of x. So if this were a cosine, we could just drop the negative and ignore. All right. We talked yesterday, if there's a negative out in front, what does that make us do to our graph? Amplitude is, and we just do the positive, the amplitude. So the amplitude is 3, period. To do period, we did 2 pi divided by the coefficient of x. Okay, x over 2 is the same thing as saying 1/2 x. So this is like 2 pi divided by 1/2. So 2 divided by 1/2 is 4. So this is equal to 4 pi. Then how do we get the count by? Period divided by 4 for the 4 quadrants, and we just get pi. The amplitude is 3. Okay, I'm counting by pi, so we have 0, 1 pi, 2 pi, 3 pi, 4 pi. Sine starts at 0 and then goes up. But I said we are going to flip this sign. So that means it will start at 0, but it will go down first. If I ask for 2 periods, what do we need to do? And then just keep following that. So it would look like that. Okay, so I just wanted to do one that had that negative on the angle. If it's sine, then you pull your negative out in front. If it's cosine, you just drop that negative. Any questions on that? How do you guys feel about this graphing stuff so far?
I think once I fully understood it, it's not great.
And that's the nice thing, like, you probably don't fully get it yet, but the stuff we're doing, we will do on every problem from here till the end of the chapter. So it's not like some things where we learn something, then we learn something different. We're just going to keep building on this. So this should just get easier for us. The last thing I want to do is try to write an equation for a graph that I've given you. So the last 2 problems on the homework are like this. I give you a picture and we're trying to come up with an equation. Now I will preface this by saying there's more than one right answer, depending on these functions. First of all, let's look at this. Does that look more like a sine or a cosine graph? A cosine, because sine starts at 0. So if it starts at its high or low point, that would be a cosine graph. Okay. But we know cosine normally starts up high. What would make it start down low? A negative. What is the amplitude of this graph? 2, because my low point is negative 2, my high point is positive 2. So that means it's a negative 2 in front. All right, let's talk about the period. We know that period is found by doing 2 pi divided by the number in front of x. When I look at this graph, the period is how long it takes until it starts to repeat. How long is, that's 4 pi. So let's solve this thing for b. So if you multiply it over the b, divide by 4 pi. So the pi's cancel, 2 over 4 is 1/2.
How did you get 4 pi when?
I looked at this graph, how long it took to get to the end. So one period ended here. After 4 pi, it's just going to repeat the same thing. So that means the coefficient on x has to be a 1/2. So my graph is negative 2 cosine of 1/2 x. That one okay? Let's do one last problem like that. So is this one sine or cosine? Is it flipped? No, because sine always goes up first. Amplitude, what are my high and low points?
4.
So it's 4 sine of, and then we just need to figure out this angle. So
2 pi.
my period, I graphed it all the way to 2 pi, but how many periods? Yeah, after pi, doesn't it just do the same thing again?
Okay.
So my period is actually pi. So we know period is found by doing 2 pi over b, and we get pi for that answer. So if you multiply over the b, divide by pi, so b is 2. So it's 4 sine of 2 pi. Okay.
Wait, so is the period 2 or is the period pi?
The period is pi.
Because after pi is
Even though I graphed it all the way to 2 pi, I just graphed 2 complete periods here. After pi, it started repeating itself. All right. So I want to give you guys a little time to work and ask questions. And so I gave you that assignment yesterday. 1 through 12 were matching. I told you to try to get those done so that you could start in on the graphing. This next chunk, these are the only 4 problems where you're actually drawing graphs, and the last 2 are writing their equations. So you've got a few minutes to work now. But we're going to be talking about 2 other changes that we can do with it. And this will wrap up like every possible variable that we can have in here. So we've already talked about how we might change the amplitude and we might change the period. The other 2 things we can do with our graphs are shift them left and right or up and down. So when you move a sine or a cosine graph left or right, that is called a phase shift. For us, we are just going to add one more piece to our list of information that we do when we graph. So let's take a look at this example. And I would probably just put this one down in my notes. I want to graph y equals the sine of x plus 3 pi over 4. So the difference here is that I added something into my x. That's what we have not had before. When I go through my list of information, it's the same as we have been doing. So we will still do the amplitude, period, and count by. What is my amplitude? 1. Period is 2 pi divided by the coefficient of x. This is just a 1x, so it's just 2 pi over 1, which is 2 pi. How do we find the count by? Yep, period divided by 4, so we get pi over 2. Okay, all of that stuff is what we have been doing, what you were doing on those 3 or 4 problems that you had to graph on your homework. We are going to add one more thing to it. So, if you remember from transformations, when you add or subtract with the x, it moves your graph left and right. That can sometimes be a little bit confusing with these trig functions, so I like to do an interval. For my interval, I am going to set this up. When I take the normal sine graph, the original sine graph, where does it start and stop? Starts 0 and it ends at 2 pi, right? The normal one. In the middle, I want you to put this argument. So that's x plus 3 pi over 4. Then I want to take this inequality and I want to solve for the x. So what would I have to do to get x by itself? Subtract 3 pi over 4. So I would get negative 3 pi over 4 less than or equal to x less than or equal to 2 pi minus 3 pi over 4. So it's like 2 minus 3/4. So that's 5 pi over 4.
Why wouldn't the pi's cancel out there?
Because we're not dividing, we're just subtracting. All right. Is everybody with me here? So now we're going to draw this graph. I only asked for 1 period, so how many total points do we need? The starting
4,
and then
5.
4 after it, yeah, so 5 total. Okay, but things are going to change a little bit. My high point is 1 and my low point is -1. But I am not starting my graph at 0 this time. If I look at this, where should my first point be? Negative 3 pi over 4. Then we are going to add our count by to get each of the other points. So if you need to use a calculator, you have negative 3 over 4. Our count by is pi over 2, so plus 1/2. And when we do that, we get negative 1/4. So that's negative pi over 4. Everybody with me here? We need 5 total points, so I need to keep doing this. So if I add it, again, remember, these should be evenly spaced out. So this is where it kind of gets harder, but it should be the same distance between each of these. So if you add your 1/2 to that again, you get a positive pi over 4. If I add 1/2 again, I get 3 pi over 4. I have 4 points, we need 5 total, so add 1/2 again, and I get 5 pi over 4. You'll notice, look at the interval we set up. We said it should start at negative 3 pi over 4, and it should end at 5 pi over 4. That was our first and last point. Then we're just sketching in the graph. So sine always starts at its 0 point. So this is our first x value, so we start at 0. Then sine goes up to 1. So at negative pi over 4, we should be at 1. My next point was at positive pi over 4, so we should be back to 0. 3 pi over 4, we should be at negative 1. And 5 pi over 4, we're back to 0. I only asked for 1 period, so that's all we have to do. If I had 1 and a second period, we would just add 4 more points onto the end. All right. Did I lose anybody there? Let's do one more of those. How about this one? So we go through our normal list. What is my amplitude?
2. We would flip it.
Yes, amplitude is 2, but because there's a negative, I know I have to flip. Period is 2 pi divided by the number in front of x, which is just 1. So 2 pi over 1 is 2 pi. Count by, how do we find that?
2 pi divided by 4.
Yep, period divided by 4, so we get pi over 2. Now, the interval is the new piece. You're not going to need it on every problem, but you could set it up on every problem. So if you don't know if you need it, do it. When do you have to set up an interval?
Okay. X minus or plus
Yeah,
something.
if it's x plus or minus something, then we have to set it up. So for my interval, normally sine and cosine start at 0 and end at 2 pi. And then you just put your argument in the middle. So if I want to solve that for x, what do? Add the pi over 3 to everything. So 0 plus pi over 3 is pi over 3, less than or equal to x, less than or equal to 2 pi plus pi over 3 would be 7 pi over 3. So all this is doing is shifting our graph over. So it's changing where we start and stop. Then we graph like normal. My amplitude was 2, so my high point is 2. My low point is negative 2. Where is the first point I need on my x-axis? Pi over 3. And we need 5 total points. Okay, so to get the others, we just add our count pi. So pi over 3 plus pi over 2. So 1/3 plus 1/2 is 5 pi over 6. Plus 1/2 would be 4 pi over 3. Plus 1/2 is 11 pi over 6. Plus 1/2 is 7 pi over 3. Quick check, your ending point should be where we said our interval would end, and it is. We're graphing cosine, so my first point happens when my x is pi over 3. Cosine normally starts at its high point, but this time it was flipped, so we will start at negative 2. Then we hit our 0, positive 2, 0, back to negative 2. And so there is my cosine. So just to summarize, section 4.1 is due tomorrow. If you would like to start section 4.2, so tomorrow I'm going to do probably 3 more examples and then give you guys time to work. We are not ready to do a lot of the homework, but if you wanted to start, there are a few that you could easily do. 15 through 18 are just matching questions. Um, 25 and 27, just all I want you to do on those is list out your amplitude, period, count by, and interval. You are not graphing 25 and 27. It just asks you to go through the information. So 15 through 18 are matching. 25, 27, you're just listing the information. The only ones that you're actually graphing are 33 and 35. Like I said, I'm not done with this. I will add to that list tomorrow. But if you have some downtime today and you wanted to get a head start, then you could start on those. Tomorrow I'll wrap up that section and give you guys time to work in class as well. Okay?